In this lesson, we'll be graphing linear functions, and we'll be interpreting the slope, rate of change, and intercepts in terms of the context that's given. Here's the word problem. On Halloween, Mrs. Jones had Snickers bars to give out to trick-or-treaters. She gave each trick-or-treater the same number of candy bars. The equation below models a situation, y equals 28 minus 2x. And we are asked to graph the equation, and we also have a table of values here that we can use. This is a drawing on Google Docs, which can be edited. And so we have some text boxes here. If 0 trick-or-treaters comes to her home, then she still has her 28 bars. If 1 trick-or-treater comes, 28 minus 2 times 1 is 26. But if 2 trick-or-treaters come, 28 minus 2 times 2 is 24. And now we can look for a pattern and extend it. I can see that I'm increasing by 1 here on my x's. And as x increases by 1, the number of candy bars decreases by 2. That's going to have something to do with my rate of change. And then what I can do is I can add a shape here. And it's going to be a circle, a little circle. I like to change the color. They automatically give you this light blue, but I'll make it kind of more of a chocolate color here. And this particular dot is going to represent if 0 trick-or-treaters come to her house, then she has 28 Snickers bars left. But if 1 trick-or-treater comes, she has 28 left. And I'm just using I have a Mac, so I'm using Command C and Command V to put these dots where they belong. And these dots would continue, right? Until she has what? How many candy bars left? Until she has no candy bars left. Okay, so that's enough of that. Now let's use that information and answer these questions. Question number 1, what is the rate of change? Well, we already talked about the fact that the rate of change is -2. And what does -2 represent in the context of this problem? As the number of trick-or-treaters, so we always start with as whatever this independent variable is, as the number of trick-or-treaters increases by 1, the number of candy bars left decreases, right? That's why it's negative by 2. Now, where do we see that in the equation? We see right there, that is your rate of change, the number that the coefficient of the x. And what is the y-intercept in this problem? Well, I can find my y-intercept in my table of values. It's the number that corresponds to 0. I can also find it in my graph. It's the dot that goes through the y-intercept. So 28 is my y-intercept. And what it means in the context of this problem, as you know, to begin with, there were 28 candy bars. In other words, it's called the initial value. That's how I interpret that linear function in context. Now the x-intercept, it didn't ask me, oh it did, here's the x-intercept question, so we can pull this up so we can see it, because I'd be surprised if it didn't ask me about the x-intercept. What is the x-intercept? Well, it's the value that x would be 0. So at what point would did I say x equals 0? It's the value that y would equal 0 is what I meant to say there. So how many trick-or-treaters into this would Mrs. Jones have 0 candy bars left? Well, if she started with 28 and every kid gets 2, I believe that 14 into this, she'd end up with 0 candy bars left. So her x-intercept is going to be 14. And it means that when 14 trick-or-treaters come to her house, right, when x is 14, she'd have 0 candy bars left.